He's late.
Oh, you know what?
Okay, if you guys can turn to page 8, I think we got through creating those vectors, so we'll go to page 9. Okay, so more of the same. We're just working with Pythagorean theorem and tangent, inverse tangent to get to the angle. Okay, so page 9. Okay, so at the top of page 9, Harry's trusted owl Hedwig can fly over buildings. So she travels in a straight line from each stop to the next and waits for Harry to arrive. On Tuesday's graph, use a different color to draw arrows representing the owl's path. Okay, so how far did Hedwig fly to get to stop 1 on Tuesday? This is known as the magnitude of the flight. So Pythagorean theorem, right? We can get to that hypotenuse by just going through square root of a squared plus b squared. And units is in terms of number of blocks. Okay, leave it like that, or calculator can take out the perfect square there. This is 4 times 5. I can take out square root of 4 is 2. Okay, there are several ways to describe L's direction during this leg of the trip. We could simply say she traveled northeast, but this will not be precisely accurate or an exact description. Okay, so it's not just northeast, right? It's specifically, because northeast is just anything between 0 and 90 degrees. Okay, so northeast, it's just a angle measure between 0 and 90. So first off is that this is not going to be 45 degrees, right? So either you can say northeast is 0 and 90 degrees, or you can say it as or 45 degrees, but neither is correct, right? So this is northeast is too vague, or if you say it's 45 degrees, that's not correct either. Okay. Okay, so it's not an accurate description of the exact description of the exact direction. We're going to find that direction here now. Okay, we can find theta. Now we can involve inverse tangent, right? So theta is inverse tangent of b over a. Okay, so it's y over x, b over a, 4 over 2. Make sure you are in degree mode. Round to 2 decimal places. Okay, so next stop, if we look at Tuesday's stop 2, we might say that Hedwig flew northwest, but it would not be an exact description. What's the possible range of values for all angles measured in standard position that are generally pointing to the northwest? So in a general direction, we know northwest is anywhere between 90 and 180. But we could also say the exact northwest is 135 degrees, right? So you can either say northwest is kind of like a general direction, but you can also say exactly northwest can also be 135 degrees. Okay, so find the magnitude and direction of Hedwig's path from stop 1 to stop 2. So if you look at stop 1 to stop 2, we know he's going to end up previous page here. Stop 1 to stop 2. So we're going to just create this triangle here. All right, figure out the length and or the horizontal and the vertical. And then we got to get our angle measure in standard position. So whatever angle we get here, we got to involve 180, right? Okay, so let's try that from stop 1 to stop 2. Okay, magnitude is just finding the length of this hypotenuse. All right, any adjustment needed here? Yeah, we have to, second quadrant, right? We know it's going to be 180 minus this reference angle that's in front of us. Yes.
I still don't quite understand why you need to subtract 180 from.
Let's see, say it again.
I'm kind of confused on why you need to subtract 180 from the degree of
Okay, the reason why is because you see how this angle is pointing in the into the second quadrant? And we know that 36.9 degrees is not quite second quadrant, right? That's more of a first quadrant. So anytime that your direction is in the second or third quadrant, we have to always either add or subtract 180 from 180 to figure out where that arrow is headed.
Okay.
Yeah. Yeah, that's only second and third quadrant, you got to involve 180. Fourth quadrant, you'll involve 360. But if it's in the first quadrant, you just leave it alone. Whatever first quadrant is, number 1 or atop the page, right? It's already pointing northeast, so first quadrant, whatever your reference angle is your measure. Okay, good. Any questions? Okay, more of the same on page 10. Anybody still need this page? All right. Magnitude and direction from stop 2 to stop 3. So go back to your diagram. Look at what you created from stop 2 to stop 3. Okay, there's my stop 2 to stop 3, right? There's my triangle. Okay, what I have is the reference angle. What adjustment is needed here? Yeah, third quadrant, right? So I need to start at 180. I need to add that reference angle to get to a measure that's in the third quadrant. Okay, stop 3 to stop 4. Look at your diagram. Okay, stop 3 to stop 4. There's my vector. There's my horizontal. There's my vertical component. There's my triangle there.
negative.
Right. 14 degrees. Well, we can just say that as a reference angle, and then we can adjust it to something that's in standard form. So what adjustment is needed here? Fourth quadrant, so 360 minus. Yeah. Mm-hmm. Okay, any questions here? All right. Next up, it says Ron sets out from Hogwarts to Shrieking Shack to meet Harry. What direction does he take for the shortest path that follows the town square blocks? So we see if he's going to go from Hogwarts to this fourth stop, he's going to have to go 3 blocks west. Is that right?
Yeah.
Or 1, 2, 3. Yeah, 3 blocks west and 3 blocks north. Okay. Okay, how does this route compare to the overall displacement of Harry during his errands on Tuesday? Now, we see that they're going to take a different path, but they're both going to end up in the same place, right? So this is the path that that Harry's going to take. So he's going to walk this entire path, but he's going to end up with the same displacement as Ron does, because Ron takes the shortest path from stop 1 to stop 4, but ultimately Harry travels a longer distance, but the displacement is simply what's the distance between your starting point and your ending point. And we see that the displacement for Harry and Ron is the same. Right, obviously Harry traveled a much shorter distance, but displacement wise, they're the same value. Remember, displacement is just comparing the distance between your starting and your ending location. Okay, the way that we've expressed Harry's routes is known as component form, since it's made up of 2 parts or components that describe the change in horizontal distance and vertical direction, right? Every vector that we created was all formed out of horizontal and vertical parts. Think of it as the horizontal and vertical portions of the right triangle that connects the hypotenuse together. The way that we've expressed Hedwig's path is known as magnitude direction form, since it gives the distance directly to each stop in the angle measurement for the direction of the flight path. Okay, we're finding the magnitude and finding the direction, and we're finding out the exact direction and the length of the hypotenuse. Okay, it's important to be able to convert from one form to another. Practice the skill by filling in the table for Harry's routes on Wednesday. Use Pythagorean Theorem, trig, and inverse trig. Remember to include units. Okay, we'll think reference angles here. Okay, so Harry's going to go 6 blocks east, 3 blocks north. We're just going to have this this coordinate plane so that we can kind of map out our progress. So 6 blocks east, 3 blocks north. We can find the magnitude and direction of Hedwig's progress by going through a Pythagorean theorem. And the direction we can use inverse tangent, right? So 6 east, 3 north. Basically, we're just doing Pythagorean theorem to find out that length of the hypotenuse or magnitude. Direction is use inverse tangent. This is pointing in the first quadrant, so whatever reference angle we get is going to be the same answer. Thank you so much. Okay, so now we're given information from the flight's perspective. Okay, so 16 blocks traveling at 113 degrees. So we're going to have to sketch out 113 degrees is going to be in the second quadrant. So if this is 113 degrees, what is the reference angle that we can create to help us find the horizontal and vertical components here? Yeah, and how'd you find that?
80 minus 113.
Yeah, 180 minus 113, right? Get that angle measure there. So this is the flight path of Hedwig, but then if Harry was to make that progress using horizontal and vertical movement, he's going to have to go horizontal west some distance, and you got to go north some distance. And we got to figure out that by using sine, cosine, or tangent. So if we want to solve for x, we can use, okay, we don't want to involve y. If we want to solve for x, we can use what? Cosine, right? Cosine of 67 equals adjacent over hypotenuse. Go around to the nearest tenth. So that 6.3 tells us that Harry's going to have to walk in the west 6.3 blocks. Okay, so now we can solve for y. To solve for y, we want to use sine, right? So sine of 67 equals y over 16. Cross multiply. Okay, so here we're just see the variations. Okay, if I gave you the x and y value, you would use Pythagorean theorem and inverse tangent. If you're given the hypotenuse and the angle measure, then you'll use sine and cosine to get back to your x and y. Okay, so let's do 2 more of those variations for part C and D. 2 blocks west, 6 blocks south. So this is describing Harry's path, and then we got to figure out the flight path. Pythagorean theorem, inverse tangent. Okay, the flight path would just be equivalent to around 6.3 blocks, but obviously a lot more efficient because it's able to fly directly. Okay, inverse tangent. Okay, what adjustment is needed? This is only the reference angle here. At 180, yeah, third quadrant. Okay, try part D on your own. Okay, so this is fourth quadrant, right? 350 degrees. Okay, so 315 takes us all the way from 0 degrees to this vector here. What's the reference angle here? Okay, 45. So we're going to use that 45 for our sine and cosine. So let's target cosine first, or the x first. X, we can involve cosine. Cross multiply. So he's going to move to the right. That's in the east direction. Okay. To get to y, we use sine. Okay, any question? Yes, question.
Wouldn't y be negative something?
Uh,
Oh, wait.
yeah, because we're specifying the direction, so we don't necessarily have to indicate the sign because we're saying east and we're saying south. But yes, you could say y is negative 7.1, and that would be the same thing as 7.1 south. Yeah. Okay, any questions? Okay, so here's the plan. Tomorrow, I would like to get through the next two sections. There's not a whole lot to do. So we'll cover the next two sections, but we're not going to really jump ahead. And then Friday, we can just work on these the practice problems on page 13 and 15. There's quite a few problems, so I would like to split those problems up into 2 days. But I'd like to get through both sections. This is not a whole lot. Tomorrow and then Friday, you'll just practice the problems. We'll do a few problems from each section. And then Friday, you'll spend the rest of the time just finishing the problems on page 13 and 15. Okay, so pretty easy week. I'm gonna come around and check you guys off, and also gonna hand back your your test as well.